Hello everyone, thank you for joining my session today. I'm going to share with you our experience with Reactive Streams API and all dangers we met across our journey. So first of all, let me introduce myself. My name is Kuzma and I start my software development career in the last century. In Deutsche Bank, I work in technology ecosystem behind FX trading platform for the last decade. So let's start from the Reactive Streams API, what it is, how it works, and what is the difference between Reactive Streams API and just regular Reactive API. Please raise your hands who are familiar with these interfaces. Quite a lot of you. Okay, I'll be short. There are one corner interface is named subscriber who receive your data. You have interface like publisher, your data source who provides data, and some means to control data flow named subscription, where you say, I need the next n elements, or I don't care about other stuff, just cancel the subscription, I will do my job later. It's very convenient API for very narrow set of scenarios. So in the scenario when you have a sequence of identical objects and you meet requirements for this sequence life cycle, like completion, like error handling, or cancellation, these scenarios would fit Reactive Streams API beautifully. But it's not the silver bullet. It doesn't fit all scenarios around. For example, a lot of you pay monthly bills to your water supplier. Just imagine you implemented water flow with your hands, provider gave you tap to control your data flow, and you play with cold hold valves to feel water flow, its temperature, its flow rate, and so on. It's Reactive API. You feel reaction on your controller, but this particular domain model wouldn't fit Reactive Streams API. So be careful, in your domain model, Reactive Streams may not fit, and you will need to think of another alternatives for your particular component, for your application. But if you already decided you meet all requirements of Reactive Streams API, you will need to choose some implementation to take into your component. There are two, the most famous ones. First is Project Reactor, and the second is RxJava. I'm more familiar with RxJava, so my next examples would come with RxJava. It's just a small example how how RxJava API looks like. There are two main concepts. First one is processor, second one is flowable. Processor is some kind of mixer. You can feed this mixer with any data from anywhere, from database, from messaging stream, from some kind of batch processing. You just feed your data. It don't care how it would be handled later. On the opposite side, the same processor would look like publisher, and it would behave according to all contracts required for publisher by Reactive Streams API. The second concept, beside processor, is flowable. It's some means to build pipeline to transform your data flow. You can change events, you can split events, you can merge different sources into one, you can cut, handle some errors, you can replay a lot of stuff. This API allows you. And the most beautiful part of these APIs is documentation. I love RxJava exactly for this part. It's really convenient. You can pick up Java documentation in IDE and just by single glance understand how this particular operator would affect your data flow. You can easily choose how to manipulate your data. But to this convenience, there is an opposite side. It's too convenient. Once you solve some problem using RxJava, you are trying to think creatively and apply the same solution everywhere. I saw this particular problem a lot of times, and it actually affects your productivity in long term. Just to compare, the same code, the same sentence split on words, and first 4 are taken, printed out. In pure Java, it looks much simpler, and it would be much simpler to maintain in long term. So be careful. Don't abuse this technology. It applies not just to RxJava, but with convenience RxJava gives you, it just seen more oftenly than with other technologies. Okay, sweet part. Reactive Streams API was initially introduced to handle slow consumers. When you have more data in your data provider that consumers could handle. This is especially why subscription interface was introduced with this request and method inside. So let's give a small example. We have energized junior producer with 10 million events and slow consumer. Senior consumer comes and tells, I need 10,000s. No, millions. No, records. And next week. So you will face this. If you use RxJava or any other framework for Reactive Streams APIs, you definitely face this problem with slow consumers. So you need to think of this problem ahead of time. You need to test it and so on. Let's take a look how it behaves in real Java. Slow consumers. This is exactly the code I've showed you in present now. Yeah. Here I've chosen publish processor, and let's assume we got 10 elements initially requested, and after some time we request the next one and expect to get 11 elements in total. So how it would behave? Actually, it doesn't work. What happens? We expected 11th element, but got only 10 of them. Why it's so? Because publish processor is the only specific processor among all these implementations that skips events and doesn't deliver these events if you don't have enough requests. It's very important. I saw this problem multiple times in production code before it went to production and on the review phase. But publish processor is dangerous in this behavior. It can just skip events and don't deliver them to anyone. So let's choose some different implementation. For example, unicast processor. It's designed for specific scenarios when you have single producer, single consumer. For tests, it should be enough. Let's check how it would behave. Oh no. We ran out of heap space, and why? Why it happened? If you dig deep inside of unicast processor, you will find out, not in documentation, but inside implementation, that it uses under the hood unbounded queue. If you have a live subscription, any missed event would be put in this queue. So once we generated 10 million events, they would be put in this unbounded queue and blow up your heap. Okay, I'm sure there should be some processor with limitations. I found replay processor. It has constructor with maximum size. I believe it should be some kind of capacity. And let's give it a try. At least it should work, I guess. And no, actually, again, if you dig deep inside of implementation, you'll find out that this size we explicitly set in constructor means for the buffer of the latest events that would be delivered to new subscribers. All existing subscribers will use exactly the same unbounded queue as we saw before in unicast processors. So the main point of these three examples is the fact that processors, by default, do not support backpressure. So they do not support the main feature declared by Reactive Streams API. When you use processors, whenever you use processors, always handle this backpressure explicitly. So we need backpressure, and with our classic server-side example, we have single source, we have many consumers, and we handle these events in some kind of parallel manner. Let's check how it works. Okay. The difference with previous example is we added into our pipeline, based on our original source, some operator on backpressure. There are a lot of different operators based on this backpressure, how you would like this backpressure would behave. Either you want the latest one, or you want the first one, or you need to merge them in some way. It's up to you. You can pick up any you like. I've chosen for this demo the latest one. So I expect my subscriber will get the first 10 elements, print them out, and then it will get the last one. Let's give it a try. Maybe it works. We are lucky. Yes, we got all 10 first requests and the last one. Wonderful. But in server-side example, we need not the only one request, but several of them. So let's check how it works. And it works beautifully. Wonderful. We have all events delivered to these subscribers in the same manner it works for the single subscriber. Does anyone see the problem with this code? I think no. Okay, the problem here is you don't have two subscribers in server-side environment. You have hundreds, thousands of tens of thousands subscribers for a single data source. And in this case, if your business logic consumes just 10 microseconds multiplied to 1,000 of subscribers, it would give you latency between the first subscriber and last subscriber of 10 milliseconds. And it is a huge amount when we talk, for example, about pricing in FX domain. So we definitely need some kind of parallelization. Let's add this here. Abonniere schedulers. Yeah, simple one, new thread. And the same for the other one. It should solve our problem. I hope so. But no, what? Okay, all of them work in separate threads. It's wonderful. Still, we got not 9 millions here, but 11. We expected to have here the latest one, but when we requested 11th element, we have very extremely stale value. Why it's so? Because observer on has internal buffer. And this buffer, luckily, could be configured. Okay, let's disable it. And no, RxJava doesn't allow us to disable buffers. This is and very important thing, RxJava doesn't allow you to disable buffers for any buffer in operator. You can take concat map, flat map, or any other variations, or any other operators, and they all will have at least single element in their buffer. So let's do it the small possible one. And here the same. Okay, run. Okay, it's better than before, but still it's far from 9 millions. It's exactly the same stale value, and we don't want to see this in pricing. So maybe we should do something weird and make the pressure behind observe. Okay, let's give it a try. I saw this plays around multiple times with different developers, but in practice, why is it so slow? Okay, it passed all 10 million records through observe on operator. It could take some time. And eventually it ended up with out of space, heap space. Why so? Remember my previous part of this topic? You can't use processors without back pressure configured. Never, ever use processors without back pressure explicitly configured. Okay, let's give a try to with this part possible. And it should work. I guarantee it should work. Yes, indeed. We have all records delivered to our subscribers, and we have the latest values. Does anyone see problem with this code? Or with its result? I highlighted here. Thread. The last record is delivered on the thread where this record, where this request one, this request one was called. Just imagine if you have network stack, for example, Netty with its nile loop to handle all network traffic, and this network loop sent the last message for this subscription and requested send signal to get next item to publish into the network. And the signal should be extremely fast. But in practice, you end up running business logic and your calculations on NIA event loop, on NIA threads. If your business logic is extremely fast, you are lucky. But if it takes some time, or you have several subscribers who hit caching operator in between your network stack and business logic, you will face some bottlenecks in your throughput, and you will spend days or maybe even weeks to discover why it happened. We were lucky, we had a lot of logging and caught this problem in UAT. Still, you need to think of this very carefully when you work with caching subscriber, caching operator, whatever type you choose, you will always face this problem with threads. Does this problem actually has a solution out of the box? I can show it after the demo, after this presentation, if we have time. But answer is yes. This problem could be solved. Not simple, but it could be solved. Just give you some example. Ouch. It would look something weird like this one. And this ugly construction would behave exactly like we expect it to work out of the box for the library. Okay. So, the main point I want to show you in these examples with back pressure, not all operators are compatible. So, before using it in production code, you need to test. You need to test everything in your pipeline. You need to test load, like in production scenarios. You need to test corner cases when you exceed your expectations greatly, how it would degrade with your algorithms. And eventually, once you add these tests, you will face bugs, errors, and exceptions. So how would we deal with this stuff in RxJava? We have very complex code with tricky bug in between. So it's obvious for one screen pipeline and proper logging that we will see this exception in our logs. First of all, when you deal with pipelines, you need to handle errors. Not just handle them, but at least log them. You can't trust subscribers. When you expose your publisher to outside, you need to have some error logging. Otherwise, these exceptions, these errors would be skipped by some of your slow consumers or special consumers, and you will never see exception in your logs, and you'll never know your code has a problem. So log everything. The second problem here is exception itself. As you can see, there is no reference to the previous calls. It's the nature of asynchronous code. It's the nature of RxJava or reactive streams of any implementation. You will never have the full stack where your data, where your exception came from. So with exceptions and with errors, it's really troublesome. I had some real-life scenario when we faced a problem, and I've spent 3 weeks just to find out what the problem is, just to analyze. There was 30,010 subscriptions on client side and 30,005 subscriptions on server side. And this was mess. Below, with loads below 20,000 subscriptions or below, no problems at all. In between, 50-50. If load is huge, we have missing subscriptions on server side. And it was a nightmare to find out, first, which subscriptions were lost, and second, analyze why does it happen with high load. Eventually, with appropriate debug logging, with injecting on next, do on next in all our pipelines, between all operators, we found the issue. Still, be careful about the fact that debug with RxJava is quite unfriendly. Next thing I want to tell you is resource leaks. If you try to pass any kind of resource through reactive Java, through RxJava, you will definitely face leaks. It's guaranteed. You have no way around if you pass these values directly through RxJava. Why it's so? First of all, filtering operators, like pure filter or distinct until or skip elements or on back pressure or whatever. You will face the fact that some elements are just dropped out, and RxJava doesn't have any API to handle this situation. So if you need to pass resources, don't pass. Keep it in a golden source, pass signals you have new resource. And consumer should go directly to golden source and tell about ownership passing from golden source to consumer. When it's explicitly said, when it's explicitly passed, ownership passed from golden source to consumer, you will fix this problem with resource leaks. Exactly the same behavior you will get because of asynchronous nature of these subscriptions. For example, you have your resource passing through chain of operators, but subscriber eventually cancels this subscription, and this new message would be lost in nowhere. So the cancellation, especially asynchronous cancellation, would cause you the same leaks. Buffers in between, all buffering operators, make the things even worse. You will lose not just a single element, not a single resource, but a lot of them. Also, besides a resource like connections or open streams or whatever, there are another kind of resource, huge events. This is a very interesting situation. We played with static data distribution service, tried to play with it, to implement it based on RxJava. and passed huge objects of million bytes or tenths of millions bytes just through RxJava, and actually ended up in the fact that all buffers in between keep stale values. You don't even care about all the stale values, but they are still kept in between, and once we faced some minor network issue, just a bit slow down, our static data server blows up, just with out of memory. So never pass resource through reactive streams, through RxJava. Again, you can use golden source and bypass only signals, pass signals through RxJava. I'm not sure you will need RxJava in this case. It's another question from the first 2 points of this presentation, but still. Again, when we face buffers and buffering operators, how worse situation is. Let's give it a try. Let's look into these buffers and how would they behave. The same example. It prints just 26 letters from alphabet inside our data source and no caching operators in between. We just print all these values, what's going on. It's straightforward. We generated all the values till that. And once we requested the first value from this pipeline, we got Z, the latest value possible. So exactly like it's described in our pipeline. Source, back pressure, some debugging, and subscribe. What would happen if we add single caching operator? Run. On the very beginning, just after our subscription, this caching operator will call request 1. Just on subscription, this caching operator will call our source to generate some data. Even though our real subscriber doesn't care, it doesn't want to waste some CPU or heap, you still, just by using caching operator, will utilize your server resources. Even worse, if we add more caching operators in between, let's take a look. It would request a lot of stuff. And all these values would be cached in these operators. Even though our subscriber doesn't care about these values, it doesn't even requested anything yet, but you already spent a lot of computation and memory resources just wasting them out. Yes, you can say that it's because of buffers and we need to reduce these buffers to the minimum possible size. But again, this minimum size is 1. So any caching operator will sum up to these stale values. How much? About the same as you have number of your subscribers. So as we can see here, in total our caching operators requested 11 values even before the first value was requested. And worse, when we requested the first value, we receive stale data. Stale data. Stale. 11 stale elements before we finally received the latest one. But while we processed previous ones, this Z would also become stale. It's a problem of utilization RxJava for any algorithms where you need the most recent data. You can't use all these caching operators, and actually it becomes quite unfriendly. In the first part of the presentation, I said RxJava is convenient, but it is convenient for those flow where you don't have restrictions on your latency. So even though these caching operators and these buffers can improve throughput, they improve throughput for particular scenarios. In scenarios where you care about real back pressure, they make your things very complex. You can bypass this writing your custom operators, but writing custom operators is also a tricky part, especially their testing and so on. So I wouldn't recommend it for such flows. In summary, let's summarize all I said now. In green, I just highlighted the most interesting and things I like inside RxJava. It's really convenient. It's well documented. I show it as example to my team how we should write documentation, how we should expose our APIs. It's really convenient. But you should think of the scope where this API should be used. Especially on design phase, you need to think twice, 3 times, 4 times, discuss within your team. Should we use this technology in your project, in your component or not? This problem cost us a lot of time, a lot of efforts for several projects, several components. So be careful on the analysis phase, on design phase, to not use it when it's not applicable. With slow consumers, you should always remember to use explicit back pressure. And once you write any part, any pipeline, you need to test it thoroughly. In all ways, in all scenarios, production-like scenarios, extreme scenarios, corner cases, you need to cover every usage. Even though you think you understand how this pipeline works, even though you intuitively understand there is no problems, even if you senior developers, lead developer, don't trust anyone, trust only tests. When you write tests, you will face less issues in production systems. It would be much simpler to analyze how the system works, because debugging, especially in production, is a nightmare. I wouldn't wish this to anyone. Also, important things, resources, don't ever pass resources through RxJava, and buffers. They always add some latency, actually, to your real-life data, and bring some unexpected behavior when you work in multi-threaded environment, in server-side environment. So, danger foreseen is half avoided. I hope these hints will help you with your projects and your components and the usage of this technology. There are some links below for those who like puzzles, and for those who like hardcore puzzles, fancy stuff, and low latency, the link above. If you want to grab a copy of this presentation, just pick it up, pick it from this barcode. And for now, I will be happy to answer your questions. There is some Slido. Yeah, thank you. Slido. When would I recommend reactive programming over virtual threads? When you're stuck with legacy systems and you don't have virtual threads, you inevitably end up with some kind of reactive technology. Actually, I don't think that virtual threads or reactive programming differs in some way. They are the same asynchronous programming, and the main problem with this kind of stuff is debugging, to find out the root cause why your system doesn't behave as you expect. Actually, virtual threads are very simple, very convenient, and if I could use them, I definitely will choose to use them, not reactive programming. But actually, in corporate environment, I stuck with old versions like Java 11. Okay. Have you tried WebFLS? Does it have same issues? I've played with WebFLS, but I can't use it in our system. We started using RxJava a lot long ago, maybe in 2015, and it spread across all our system like a wildfire. So for now, to replace it with WebFLS would be quite expensive task. So we just stuck with this technology for long ago. Tried it? Have I tried it myself? Yes, I played with this technology. I've looked into caching. They have similar caching problems. I haven't looked into problems with threads model. It requires some efforts to dig in, but I hope they solve this problem. Maybe you can give it a try. I'll answer this way. RxJava looks only convenient. Why do you still use it? For the particular scenarios, very narrow set of scenarios, this is very convenient technology. It solves problems. For example, when you need to process some batch operations. For example, clients uploaded some huge file and you need to pass all these rows to backend systems. You can read it, pass to the processor, and eventually your backend system will pull all this data from your front end. So for some scenarios, when you don't care about latency, when you don't care about real time, it's really convenient and it solves the problems. For threading problem, I also mentioned before, we have our custom operators, and it's really convenient to use them. We can bypass these bugs just by using our custom operators. I told you before that I'll show you, if we have time, this backpressure operator and explain how it works. So when we need some backpressure and the latest value possible in our data source, in our processor, we can make a custom subscribing logic. So operator like flowable defer will create new flowable. Your actual subscriber would be subscribed. And for every new subscriber, this code will be called. So for new subscription, you can create a couple values and keep the latest value possible in this golden source, in this atomic reference. And later on, when consumer requests next value, this part will take hold of this request 1, request 10, whatever. And this would be observed on operator who will pass new value. It's stale. This is why we ignore it. And we replace it with the most recent one collected before on backpressure operator. Just to bypass the null problem in RxJava, I've added filter operator here. Thus, we will always have the most recent value actually generated by our consumer. If you want to copy-paste this all across different systems, it would be a waste of your time. So we can just replace it with custom written operator and move all this logic inside compose. And inside compose, all this would be just copy-pasted. So in production code, in your real-life code, you will use where it is. yeah. You will use compose operator with custom implementation instead of provided by RxJava. It's quite convenient, and again, this convenience keeps us to keep this technology and use it year and year and year and next year. Okay. What was the issue with the lost subscribers on server you debugged for 3 weeks? It actually was out of memory error. It's another one problem with RxJava. It handles errors in different ways. Moreover, different operators handle these errors in different ways. And we ended up swallowing out of memory error that killed our subscription. When I added a lot of do on next log operators in between all this stuff, I found that at some point subscriptions just stopped updating. There were no any updates further, and this pointed that something happened in this particular case, in this particular part of code. Then I've added unit tests to imitate production load in this particular point, and it highlighted the problem with out of memory. So, are you going to open source custom operators? I hadn't planned for this. I'm not sure. Maybe I'll put them to the RxJava source code, maybe contribute there. Okay. It looks like questions ended. Any questions from auditory? Second. You said debugging is a nightmare and testing is very important. How easy is testing? Actually, testing is also the strong point of this particular library. It has very convenient operators like test subscriber. I showed you in all these live demos. It has test schedulers to emulate how you will work with a multi-threaded environment, and it has a lot of assertion implemented on this test subscriber and test operators, so you can use it for any scenarios you like. Actually, the problem with testing may lay not in RxJava itself, but in thinking of developers. Developers trust the code they write. So to make your tests really a proof this code works, you need teamwork. You need either your teammate to look into tests and highlight some scenarios you haven't thought of, or you need a dedicated QA engineer who will look into the system like an API and think of its usages in real scenarios. So the problem not in technology, but in testing approaches themselves. Okay. How often do you use reactive in your projects? Very often. Actually, under the hood, we use Netty, and above Netty, there are some specific for our infrastructure layers that are bound to use reactive streams and RxJava in particular. So everywhere we use our core technologies, this RxJava is spread like a wildfire. I thought of the ways to remove RxJava from this critical part to make our applications a bit lighter, but I don't have enough time to complete this task. So we stuck with this technology, I think, for years, and we will keep using it, and it will keep spreading all around. So this question already asked. Any more questions? No. Yes. Okay, custom operator. For example, you sent from your original source 20 events. One of them was cached, and the last one cached by on-back pressure latest. When client requests single one element, it would get stale value from this cache, and it would be transformed into real latest value from here. Then reference would be replaced with skip value. Next, on the next request one, inside on observe on operator cache is empty, so value would be requested from on-back pressure latest. And there is the same value. It would pass through observe on operator to map, where the same value would be ignored, but in reference we have skip value. Replacing it with skip value in the previous stage caused us to skip twice double notification of the same value. More questions? Yeah, please. Caching problems would be also the same in RxJS. Threading problems you will never face in RxJS because it's single-threaded. We use RxJS in our client-side libraries, and it behaves much better compared to Java version. More questions? No. Yes. Go. No. Okay. Thank you very much for joining my session today. Glad to see you.